So today's session is on browsing or navigating Linux kernel source code. So Linux source code is huge and it is evolving very fast. We have 27 million lines of code, and finding out a definition or declaration of a function or a structure is very difficult. We need to use some kind of tools. So we have tools which will help us in navigating or browsing the Linux kernel source. We have tools like cscope, ctags, lxr, which allows us to easily browse the kernel source code. So we'll be looking into these tools today. The basic tool which we have is grep. So grep is a tool which comes by default on most of the Linux distributions. So if you want to find out any definitions, for example, wake underscore up underscore interruptible, using grep command, you will be using the following syntax like grep -nr, the definition or function which you want to find out, the definition of function. N is signifies you want the result to have line number, and R is for the recursive search. So suppose if I want to find out the definition of wake underscore up underscore interruptible, the Linux source code, suppose I have this Linux source code. So it will give me all the places where wake underscore up underscore interruptible is used. So grep will normally do a text string. Grep does not understand whether it is a function declaration or a function definition. It will just look for wherever wake underscore up underscore interruptible is present, and it will display the result. As we have specified n, it will also display the line number. So our requirement was to find out the definition of wake underscore up underscore interruptible. Which is not what we got. We got what all places where wake underscore up underscore interruptible is used. So we can reduce the search. So we can reduce the search to only look into for header files. So if where we can get the declaration or of the file of the function. So if I want to reduce the search, I only want to search in .h files. I can add -- include, and I can specify to search only in header files. So I can just add like this. Now it will only search in the header files, and now you are able to see that wake underscore up underscore interruptible is a macro, and you are seeing the definition of the macro which is present in fate.h. So you can directly open this vi, and you have the line number, so you can directly go to that line. So you are directly into the definition of macro. So as it is a macro, you are able to find out the definition of it in the header file, and that helped us. So, but if it is not a macro, if it is a function, then it is difficult using grep. So this command will only search in header files. If I want to search in header files and C files, I can write a regular expression like this, and I can, if for also in assembly files, I can specify capital S. So this is how you can use grep, the basic tool, but it will take a lot of time. You can see it will go to each and every file and search for them. Now, how do you find out a definition of a particular structure? For example, I want to find out definition of structure, struct task underscore struct. How can I find out? So again, the same thing. What we normally do is we do a grep and we say struct task underscore struct, and we say dot. But this is also not useful. It is giving all the places where this particular text is present. It is not giving where the structure is defined. The one of the way which we already, as per the Linux kernel coding style, is to include, they write opening brace in the same line with a space in between. So this will help us, and we will be able to find out the definition of task underscore struct. So as we know, that kernel coding style is to have a space and then an opening brace, and we know the script.h is the file where the definition of task underscore struct is present. So we got the answer. So how to find out a definition? We give the structure and then add a opening brace with a space. How do you find out now definition of msleep using grep? So msleep is a function, so it's not a macro. So to find out definition of msleep using grep, let's first search for the declaration of msleep. And the declaration of all the functions are present in include folder. So let's only search for msleep in include folder. So we now got the declaration of msleep, which is present in delay.h. Now we can search for the definition very easily. So this get the declaration and now search for the same thing in the Linux source code, but do not include the semicolon. So easy now. We were able to find out the definition of msleep is present in kernel time timer.c at line number 1954. So this is how we can use grep. If you do not have any tools installed on your machine, you can use grep, but it is you need to know most of the C logic, how they write C logic, and you need to know the kernel coding style. So if you do not want all this, you want to use tools, you can use tools. So we'll look into those tools. So with grep, it is very slow. It goes into each and every file and then it performs a search, and there is no catching there. It will not store any cache. So it will do, each time you do a grep, it will go into each and every file all the time. So we have tools which maintain a database. We'll be looking into those tools now. So first tool is cscope. So cscope is a tool for efficient navigation of C sources. So with grep, a lot of time is wasted because you will be doing random grepping. But with cscope, this time is saved as the results are displayed very quickly. So it has a faster search when compared to the grep. So cscope is faster when compared to the grep. So how can I install cscope? The command to install cscope on an Ubuntu machine is this: sudo apt install cscope. So install cscope is very simple. So you install the cscope. So it has installed cscope now. You can verify by checking the version. So 15.8. So how can I use this cscope? Now we have installed cscope. How can I use this cscope? So for using cscope, you need to generate a cscope database from the existing sources. So how can I generate a cscope database? In Linux, kernel source provide you a target known as cscope. So if you say make cscope, it will generate you a cscope database. So we are in the Linux source code. And now if you say make cscope, it will generate us a cscope database, which is the first step in using the cscope. So when I say make cscope, it will be using the default architecture, which is x86_64. If I want to use a different architecture like ARM, I can specify arc equals to ARM. Then it will use that particular architecture. But why do we need to specify this arc variable? This is optional, but the benefit of using arc is the architecture dependent functions will not appear multiple times. So if you do not specify arc, the architecture dependent functions will appear multiple times in the database. So by specifying an arc, those functions will not appear multiple times. If I run this command, the architecture dependent functions of x86 will come. But if I run this command, the architecture dependent functions of ARM will come. So in case of ARM, you will be having multiple platforms, which is sub-architecture. So if you go into ARM folder, you will be seeing a lot of machine folders there, Mac folders and plat folders. So if you want to pick one of them, you can also use sub-arc and specify what is a sub-arc, like OMAP or Raspberry Pi and on. So using sub-arc, you can still reduce the searches. So let's see whether our database is generated. If you want to find out what is this command doing, you can just do a ps -ef, and it is running this things. So make cscope, that is running this all things. So it is running cscope -b. So internally it is running a script known as tags.sh with a parameter cscope. So you have a scripts folder. In the scripts folder, there's a file known as tags.sh. So this is the file which Linux kernel runs when you say make cscope, and it passes cscope as a parameter to this particular file. And this file, this script will internally run this command, and which is again running this command. So we have our cscope generated. So you have cscope files. So we'll look into the meaning of these files. So cscope files are the list of files which are indexed by cscope. So ls minus ls h cscope. So you can see it's nearly 1.2 MB. So cscope files or all the files which are searched by cscope, and you can see as we have not specified any architecture, it is by default picking up x86 architecture. So all the architecture independent files, dependent files will be from x86. So a lot of files are being picked up by cscope. An arc x86. So it is picking up x86 as an architecture. And these all files are being added into the cscope database. So it is nearly 36,200 files are being indexed by cscope, and then it created a database. The database is cscope.out. So cscope.out is nearly like 500 MB. So it is a cscope database. Then we have two other files, cscope.out.in and cscope.out.po. Cscope uses this for speed up lookups in the database. So you will perform speed up lookups by using these files. So if I say make arc arm sabak omap to cscope like this, then it will generate, it will use different architecture files. It will use ARM specific architecture files instead of using the x86. So let's look into those files now. So it's still running, it will take time. Just completed. Now let's look into cscope files. And now you can see it is using arc instead of using x86. Now first it is specifying .h files. After it .h, it uses .c files. So you can see it's omap2, as we have said, it is using omap2 files. Okay, let's go back and clean all this and generate cscope for our own architecture. So this clean will clear all these files. We have seen what this clean is in our previous session. So it has removed all the cscope files. Now only generate cscope for our architecture. So we are generating cscope database here. So one more option which we can pass to make is compiled underscore source. So if you pass compiled underscore source equals to 1, this will include only files which are compiled. This way, the cscope database will only contain symbols which are used in the compilation process. So this way you will be having a better performance because the cscope database is very small when searching for symbols. So if you add compiled underscore source equals to 1, then only the files which are used in the compilation process will be included in the cscope database. So let's wait until cscope database is generated. So you can say it's specifying the time it has completed. So we have cscope files ready. Now to start cscope, to use cscope, there are two ways. The first way is cscope. If you just run cscope, it will try to rebuild the database only if any source file has been modified or if the list of source files is updated. So list of source files are present in cscope.files. So you can start cscope by just saying cscope. So if I say cscope, it is saying building cross reference. So it is trying to see whether any files have been updated or any files in the cscope.files have been modified, and it will update the cscope database. The other way is, if you do not want to update the database, you can specify -d parameter. So cscope -d, this will now display the cscope panels. So it has two panels. So this is a cscope UI. It has two panels, top panel and bottom panel. Top panel is where the results are displayed. This is the top panel. Bottom panel is where you can perform your search. So search queries can be performed in the bottom panel. So how can I move between panels? If you use tab key, you can switch between panels. So if I want to switch from top panel to bottom panel, I can use tab key. If I'm bottom to top panel, I can use tab key. And if I want to move in this search queries, so different options I have in the queries to search. So I can use arrow key, up arrow and down arrow key to move between the different search query options which we have here. And to exit cscope, you have to press Control D. So Control D is used to press to exit cscope. So to start cscope is cscope -d. To exit cscope is Control D. So now we have known the basic mechanism of starting and exiting cscope. So now let's find out definition of spin lock. We know spin lock is used to lock a spin lock. This is the function which is used to lock a spin lock. Now if I want to find out the definition of spin lock, let's use all the options which we have. Let's first use find this C symbol. So let's write spin underscore lock. You can see it gave us a lot of results. It's nearly 9,000 above 9 results have been displayed here. So what is this find this C symbol is doing? So find the C symbol, it will search all the instances of symbol. So whatever symbol you have mentioned, so suppose you have mentioned a symbol, spin lock. This spin lock, spin underscore lock can be a variable name like this. It can be a variable name, or it can be a function name like what we were searching for. We were searching for function spin underscore lock, or it can be a hash define, or it can be a type def. So find this C symbol will search for all this. So you can see it is searching for spin underscore lock function. It's also searching for the variable name with spin underscore lock. So everywhere wherever it find it is a function or a variable, it will search for it. So it is not giving the exact definition. It is just searching wherever the function spin underscore lock is used, or it may be a spin underscore lock with a variable name. But I want to find out the definition. So this another option. So if I want to switch from the search from the top panel to the bottom panel, I will use tab key and arrow keys to move between the search options. So I want to use find this global symbol, global definition. So I say spin underscore log, and you can see the results are only 6 results when compared to the last, which we have seen like more than 9,000 results have been displayed. So, and you can see there is a on the line, on the 6th result, number 6, you have the definition of spin log. And now if I press, I can use up arrow keys, up down arrow keys to move and press enter. Other way is you can, if you are already on the top and if you say 6, you directly go and it will jump directly on the same, on the line with the definition of spin underscore lock is present. So this is how you can directly get the definition of spin underscore lock. Very quick, just you type and you get the result. So to close the Vim, use the same option, :Q, and you will be back to the cscope UI. So find this global definition will only get the definition of the variable name or the function. It will not give the results where all these variables are used. Then we have the different find functions called by this function. So if I want to find out what all functions are being called in spin underscore log, I can use this function. So spin underscore log is using raw underscore spin underscore log. So this is only a single function which is used by raw underscore spin underscore log. If I look into some other method like msleep is using 2 functions, mseconds to jeffs and schedule timeout uninterruptedly. So using find functions called by this function, I can find out what all functions are being called by this particular function which I am searching. And I can go into the definition of those functions. We cannot directly go into the definition of those functions, but I can just find out what all functions are being called by the search query. So tab key is used to move between panels. Then we have find functions calling this function. So if I want to find out how many times spin underscore lock is being used in my kernel source code, so I can just use this particular option. So this is all. So this almost more than 9,000 times spin underscore lock is being used in the Linux kernel source code. So most frequently used function Linux source code, spin underscore lock. So we have seen 4 options. Let's look into the other options. So if you do not, if this above 4 options do not help, you can use the below options, which is find this text string, change this text string, etc. So for example, if I want to find out the definition of file, struct file. So if I say file, it will give me a lot of places where file is there. It's not I want. So I say file here. It's also giving. So let's say struct file. C symbol will search. So it's saying not a file because we are trying to find out definition. So struct file, no, it's not helping us. So just saying file is giving a lot of results. So it's giving a lot of results for us. So it's here. So we have to go a lot of places before we find struct file, the definition of the structure, which is in Linux fs.h. So if I search for something like this, it won't help. It says it is not a regular expression. So it's a regular, says error in this regular expression. So the best way is use this option, find this text string. So I can just use struct file, and it is giving us the exact result. So this will work like grep, but this is faster. Internally it will use the database. So you can see this is what, if this above 4 options do not help, you can use this find this text string. And change this text string is whenever you want to change any particular text string. and you have grep for extended grep, regular expressions. If you want to find any file like fs.h, so it is giving all the files which are having fs.h as, it is present in the file name. Let's find for module.h, all the places where module.h is present. So can I find like this Linux module.h? Yes, we can use like this. And we have limited results, which is what we want. Uh, the other way is you can find out who all are including this file. So if I want to find out who all are including delay.h, there's no one including delay. So we have to say Linux delay.h. So you can see who all are including this particular header file will be searched and displayed. So it's very useful features. So instead of remembering all the grep and all, you can use cscope and it will give the result very fast. It's easy also. So to exit cscope, you say Control D. So some tips in using cscope. If you are pressing Control B, it allows you to search for previous search terms again. So suppose I have started cscope. I do not have any, if I press Control B, it says there is nothing in the search history. So let's search for something like, if I say msleep, I got msleep definition. Now let's search for struct fs here. So I got one. So it is searching, and so it's not able to find out struct fs because we don't have any structure like that. Search for struct file. Now if I press Control B, it is showing us what all being searched in the history. So it is very, so if you want to go back to your previous searches, you can use Control B and you can see what all you want to search. So you can use the previous searches. Then you have cscope-p4. This will cause cscope to prepend the directories which are leading to a source file. So here you can see it is just displaying a file name. But if I want to see the directories, so let us open with p4. Now let us search for struct file, not file, yes. So it is now saying that fs.h is present in include Linux. Previously, it was only giving us fs.h. Now with adding p4, it is giving us fs.h is present in include Linux folder. So the other option is, if you want to disable case sensitive search, you can start cscope with -c parameter. So if I want to use cscope inside Vim, till now we were opening cscope UI and then we were trying to use cscope. But if I want to use cscope inside Vim, I can use it by using :cs. So let's open a file, let's say init main.c. Now let's say help cs will give us all the commands which are used plus cs. So this is how you can use cscope. :cscope or :cs is the main command. Then you have options for this. So sub commands are add, find, which is what we are doing. So we were using this, find this C symbol, find this definition, find functions called by this function, etc. So you have you have the main command which is :cscope or cs. Then you have sub command which is find. So example is, so find C means, so it is saying find C Vim_free. So find is to query cscope. C means find functions calling this function, which is this function. And you can either use C or you can either use this number. So this is what here. So if I want to find out definition of mutex_log, G means if I want to find out the definition, I say :cs find G mutex lock. So let's try to use that. So call cs find G mutex lock. I want to find out definition of mutex lock. So it will give us the list of where all mutex lock is defined. So you can easily find out we want this file mutex.c, and this is what we are looking for. So you can just say for cscope number. It will go directly to this file, open the file and go to this particular line, mutex lock. Now if I want to go back, I cannot go back using cscope. If I now close this file, it will close the whole Vim session. So I cannot go back to the Vim init main.c. So this is one of the problem with cscope. We cannot go back to the previous search, which can be possible by using ctags. So I'm doing out of tree module development and I want to use cscope. So suppose I have this file hello.c. I want to find out definition of copy to user. So if I want to find out definition of copy to user. So I will say cscope find global definition of copy to user. So it says no cscope connection. So this means whenever you are opening cscope, you should be in a folder where you have cscope.files or cscope database. So till now we were starting cscope in the folder where you have cscope database. So say now when you try to open cscope from a place where you do not have this cscope database, it says no cscope connections. So how can I do that? How can I use already existing database? I have to use like this. If I'm doing out of tree module development, I have to say like this. So give the path of the cscope database, absolute path, and also the path of where the kernel is present. So let's add this. This is where my cscope.out is present, and this is the path of my kernel. So let's add this here. So I have added the cscope database to this Vim session. Now I can use copy to user, and I'm directly into the copy to user by cscope find global definition G copy to user. So very easy, and you can easily find out. You can directly go into that file where the definition of copy to user is present. So this is how you can use cscope for out of tree development where the files are not in the Linux kernel source code. So instead of typing the whole :cs find G and the symbol name, we can add shortcuts to your vimrc file. For example, if I want to find out the definition of a function by using control@ or c@, I think it's c@. So if I want to find out definition of a function using c@, I can map that particular short key pair to this particular thing. So I have already added this in my vimrc. If your vimrc file is what Vim will first use and load this file before opening your actual file. So now I can use, so if I go there to my previous file, I first need to add my cscope database. I've added my cscope database. And I can go to a function where copy to user is present, and I say control@. So somehow, so you will get where all cscope copy to user is present. And you can enter that number and you can go there. So there's a plugin which is already available, which performs some of the shortcuts. You can add shortcuts. So this is already adding shortcuts for some of this. So C/S. So it is saying if you want to do a CS find as, you can go to the particular, you can place your cursor there, and you have to hit Control slash and then S, and the result will be displayed in the current window. And you can use Control T to go back where you are before the search. So this plugin you can copy. So it has given instructions. So you can copy this into your vimrc file, and then you can use these shortcuts. So you have any queries in cscope? So let's move to the next ctags. So ctags is another uh, tool using which you can browse the source code. With ctags, you can jump from the current source file to the definition of functions and structures in other files. So this is what was not provided by cscope. You need to add a vimrc file and all. So with ctags, it is by default. You can jump from the source file to the definition of functions and structures in other files. So how to install ctags? Sudo apt install. So let's install ctags. So we have installed ctags. How to use the ctags? Like cscope, you need to build the database for ctags. So we said make cscope for generating the database. Similarly, make also provides, Linux make also provides a target for ctags database. So make tags. So if you say make tags, it will generate a database for ctags. So you can also verify what it is doing. So it is again running scripts tag.sh script, which is present in scripts folder, and it has now provided tags as an argument to the script, and this is running internally. It is running ctags command. It's taking time to, so you can just, it will take time to generate the database. So like cscope, you can also specify architecture as well as, for suppose if you have ARM, you can also specify sub architecture. So it tries to store the index in a tags file. So like cscope.out, we have tags file here in ctags. So it will take a lot of time for generating the database. So it has generated the database, nearly 490 MB. So if you say file on this, so ctags, tag file. So you can open this file and you can see it's in a very big file, so it will take time to open in VI. So it's included all the files. And you can see it is having a particular format in which it is storing the files and the variables and symbols. So how now we have generated the database. So how to use this? How to use this ctags? So when you open VI by default, Vim will expect a tag file which is named tags, which is what we have seen here, tags, in the current folder. In the current folder. So if I open kernel semaphore locking semaphore.c, it already has loaded the tags file. So no need of loading a separate tags file because Vim expects it in the current directory where you are opening Vim. Now if I want to find out definition of a function or structure, I need to take my cursor wherever my function is there or structure is there. I need to press this control square bracket, closing square bracket. So suppose I want to find out definition of likely or this Raspberry. Second control slash, it is giving me two options. So I can say second, and I'm directly now in definition of raw spin lock active self. So I can go back to my previous file from where I have executed control opening closing square bracket by pressing control T. So when you say control T, you'll go back to the file where you were, from where you had called control slash, or where you are calling jump to definition. So two important shortcuts which are which you need to use, which you need to remember if you're using ctags, which is control plus closing square bracket to jump to definition, control plus T to return from definition. So those are the important things which you need to remember. So as I control this, I can have places. I can now directly go to where those are defined. And to return from those, I can say control T. So two important shortcuts, and then you will be easily using ctags, and you can be moving back and forward between definitions and function calls. So cscope, ctags also provides help in them. So if you say help tags, so it will show you all the commands which we can use, like TA, G and all. So these are the advanced commands which we will not be looking into. But if you want to read more about tags file, how the tags file is present, you can read this help. So like I can just open Vim and I can search for definition of start underscore kernel. So this is how I can search for the definition of start underscore kernel. And it is showing me there are two places where start underscore kernel is defined. One it is here, it is declared and defined in second place, and I can directly go there. So no need of opening the whole uh, file and then search. I can directly just open Vim and I can search for the definition. So this is how you can do. If you are having multiple definitions for a particular tag, I can use TN to go to the next definition. So if I say TN now, it does not have any other definitions. So it says cannot go beyond the last matching tag. But if I say, if I press 1, this is the first instance of start underscore kernel. Now if I say TN, it will go me the second place where start underscore kernel is present. If I use TP, it will go previously. So TN and TP are used to go to the next definition for the last tag or to the previous definition for the last tag. So again, if you want to find out histories, you can use colon tags. So we have only searched for start underscore kernel, so it is only displaying that as in the history of the ctags. So there are other commands. So if I say control plus W plus closing square bracket, it will open the definition in a horizontal split. Suppose I am here, I say TN, I go there. Now I want to find out the definition of this. I can say control this, closing square bracket, it opens the file. But if I want to open a horizontal, separate horizontal frame, just a second. So controls closing square bracket will open in this new, open the VI with a new file where the definition is present. If I want to open in it, if I want to split the window, I can say control W and slash. So this is how I can see the definition in the horizontal split. So you can see in the top, there's a definition of the file stack, which we were searching, set task, stack and magic. I can close that file and I only have this. So control W this, and I can move in this file, the above file. Also, you have like, you can use G plus this to get a list of matching tags. G plus closing square bracket. Suppose I'm here likely. I want to find out the list of matching tags or struct semaphore. If I say control slash also it works. Sorry. G is for the definition. So this is how it works. G closing square bracket, and you can select any number, 6, and you can directly go the definition. Control T will get me back to the previous file. And I can also open using vim-t tag. So if you start VI and say vim-t start underscore kernel, directly opens me to the file where the start underscore kernel is defined. So very useful features. Ctags is very nice. So not much we have to do. Shortcuts are already given by ctags. For cscope, we need to define those shortcuts. Again, for out of tree modules development, we have to set like which cscope, which we have added cscope database by using set cscope add, cscope add. We said cscope add. For tags, ctags, we have to set tags like this. So let me open that file. Now if I say without adding that, if I try to go to copy to user and say control closing square bracket, it says tag not found. But if I add my tags, and if I say control this, I'm directly into the definition of copy to user. So very useful, and I can come back by saying control T. So this was not possible by cscope. We need to add those plugins But with ctags, it's very easy. No need of extra stuff. Just install ctags and control closing square bracket and control T will help you move between function call to the definition. So as we said, Vim expects the tags file in the current directory. So if I go to cd kernel locking, so this is what it's called here, location locking. Now if I open semaphore.c at line number 182, now if I want to find out definition of this, if I say control closing square bracket, it says tag not found because it will see tags will expect Vim expects the tags file in the current directory. So you can avoid this by adding this particular line to your vimrc. So what this line will does is when Vim will try to locate the tags file first in the current directory. If it is not found, it will look into the parent directory until it finds a tags file. So if you add this line, Vim will first by default look into the current directory, then into the parent directory, then into the parent of the parent, and so on until it finds a tags file. So let's add this into the vimrc. This is how we should add. Now if I say control slash, it works. So wherever you are, it will work because the parent of parent is where the parent folder is where the tags file is there. So tags file is parent of parent here. So we will find that file, tags file, and it will work. Vim supports tag name completion. So cscope supports a feature known as autocomplete. So using Vim, you can use the feature of ctags to autocomplete. Suppose you are here. You have added tags file. You have added tags file now. Now, if I try to say msleep, and if I want to autocomplete, I can just say msleep and tab. So not like that. So tab msleep, not tab, tags. So it's only tab msleep. If I say tab, it will give me the results, different results of msleep. So I can find out whether msleep is just msleep or interruptible, like this. So colon tag msleep and it will work. It will give me different msleep which starts with msleep, tags which start with msleep. So question is, can I list all the references of a symbol in Vim using ctags like cscope? We know with cscope, I can find out who all are calling this my function. So can this be possible with ctags? It's not possible with ctags. That feature is only present in cscopes. With ctags, it is not possible. So what are the differences between ctags and cscope? So very few differences. Differences between two are small. Using ctags, you can use autocomplete for function or variable names. This cscope does not provide this feature. So ctags allows you to jump from function calls to definition using control closing square bracket. There is no key bindings for cscope by default. You have to manually add it in the vimrc file. So cscope allows you to list all the instances where a function is called. This is not possible with ctags. Cscope is great for bigger unknown code bases. So these are the differences, very minor differences. So this is an assignment for you, like download the glibc source code and use ctags and cscope to find the definition of stdout, stder, stdin. Also, you can find out definition of open system call. So download glibc source code. You can find out glibc source code online, and then use ctags and cscope. First, generate the database, and then use the ctags shortcuts or cscope commands to find out definition of stdout, stder, and stdin. So we have completed ctags. Let's finally look into LXR. So LXR is a code indexing tool with a web interface. So it allows you to perform all what you are doing with ctags and cscope. Like you can search for identifiers, functions, variables, or you can look for the function declaration or definition. So let's open this LXR. So this is a web interface. You can see at the right side, you have a lot of tags. You can search any of the Linux kernel here, which you are working on. So almost all the kernel versions are present. Also the release candidates are also present. Now if you want to use RC6, and now if you want to search for say spin_log, giving us where all it is defined, where all it is referenced. You can click on this, you jump directly to that particular file along with the line number. So it's a web interface. You need to have internet connection for this. So using just clicking on the particular line or the function, you can go to the, it will give you the results, like where it is defined and where it is referenced. So let's do quiz. Dash contains a list of files which are indexed by cscope. It's cscope.files. Is grep faster than cscope? No. How do you exit from cscope? What is the shortcut for exiting from cscope? Control D. Cscope supports auto completion. No. ctags supports auto completion. Yes. Can I list all the references of a symbol in Vim using ctags like cscope? No. LXR is code indexing tool with web interface. Yes. How can I return from a definition using syntax? What is a shortcut? Control D. Okay, the previous we have not seen perfectly. Let's do it again. Cscope files. Grep is faster than cscope. No. Control D. Cscope supports auto completion. No. Yes. No. Yes. It's Control D. Jump to definition. Ctags jump to definition shortcut for ctags. It's control closing square bracket. Perfect.